In this lesson, we'll see method of components of a force to analyze the equilibrium of a body under the action of a given set of forces. To begin with that, let us say we have a body as shown here, and assume that you have x and y axis attached to the body as shown here. We can choose arbitrarily any one direction as x-axis, and the other direction which is perpendicular to x-axis is the y-axis. And suppose that you have several forces acting on it, F1, F2, F3 and so on. Let us say this is F1 bar, this is F2 bar, this is F3 bar, and so on. Let us say this is Fn bar. Then we can easily see that the x component of resultant of these forces is the sum of x components of all the forces, F1 x bar plus F2 x bar plus so on up to Fn x bar. Similarly, you can say that y component of resultant of the forces is sum of y components of the forces. So we'll write so on up to Fn y bar. And we know that for equilibrium we should have magnitude of r bar should be equal to 0. That would mean that the sum of magnitudes of forces acting on it, that is Fi x bar as I runs from 1 to n, which is sum of F1 x bar plus F2 x bar plus so on up to Fn x bar should be equal to 0. Similarly, sigma I is equal to 1 to n Fi y bar, which is sum of F1y plus F2y so on up to Fny equal to 0. These two conditions are the conditions of equilibrium when a set of forces, concurrent coplanar forces, are acting on a body and they are keeping an object in equilibrium. We'll quickly try to go over a example problem as shown here. We have two rollers. Let us say we name them as roller 1 and roller 2. Okay, these two are contained in a triangular trough, see, formed by an inclined plane. This is an inclined plane and a vertical plane. Okay, you have 3 points of contact, one point of contact at point A, another point of contact at point B, and another point of contact at point C. 3 points, these three are touching. Okay, if you try to see the number of forces acting on each of these rollers, roller 2 is touching roller 1, the inclined plane, and it has a gravity force. It has 3 forces acting on it. Whereas if you see roller 1, it is touching at point C, point A, and a point of contact with the roller 2. Let us name it, let us say some point P. So at C, A, P it is touching, so it has 3 forces, and the fourth one is this Q. Okay, so for this roller 2 we can use Lami's theorem. For this roller 1 we'll use method of components. To apply Lami's theorem for roller 2, we'll quickly draw the free body diagram of roller 2. For doing that, we'll try to draw the roller 2 as shown here, and then we'll quickly show all the forces acting on it. This is force Q, weight of the roller, and then this roller 2 is touching inclined plane at point B, so you'll have a force as shown here which we call RB. So you have RB acting as indicated here, and we can very quickly find out what is this angle. Since this is 90 degrees and this is 30 degrees, this better be 60 degrees. So you have this angle as 60 degrees. And then this roller 2 is touching roller 1 at point P. While doing so, this roller 2 is trying to push onto roller 1 as indicated here in this direction. Thus roller 1 will exert an equal and opposite reaction as shown over here. This reaction we can call F12. Okay, and this angle is 30 degrees. The line of centers here is parallel to the inclined plane. The line joining centers of 1 and 2 is parallel to the inclined plane. So if this is 30 degrees, this will also be 30 degrees. So now we can apply Lamy's theorem for roller 2. To apply Lamy's theorem for roller 2, you will draw the forces as shown. Force Q going down, force F12 going up like this, and force RB going like that. So this is F12, this is RB, and this is Q. Okay, we know this angle is 30 degrees and this angle is 60 degrees, and thus this angle is 90 degrees. Okay, and this whole included angle between F12 and Q is 120 degrees. This angle between RB and Q is 150 degrees, and thus we can write an equation for Lamy's theorem as Q divided by sine of angle between the other two forces, which is sine 90, which is equal to Q by 1, and then you have F12, the other force, divided by sine of 150 is equal to RB by sine of 120 degrees, which would imply F12 is Q is 445 sine 150, that is 445 cos 60. So F12 comes out to 222.5 newtons, and RB comes out to 445 sine 120, that comes out to 385.4 newtons. Okay. A similar thing we'll try to do for roller 1, that is, we'll try to draw the free body diagram of roller 1 and try to identify the forces. So we'll try to draw FBD of roller 1. Okay, you have roller 1. Let me try to draw it a bit below. You have roller 1 like this with weight acting vertically down. This is Q. You have one force exerted as indicated here. This force we will draw as F21, force exerted by 2 on 1. This will be equal to F12, which is equal to 222.5 newtons by Newton's third law, and we can show this angle as angle 30 degrees there. And you have another force, that is what we can call RA acting, and this angle as usual is 60 degrees. We can very easily see that. And a fourth force we have here, that is reaction at C. Okay, since there are 4 forces, we'll use method of components to solve this, and to do that we'll set up x-axis like this, okay, and y-axis like this. Okay, doing so, note that positive x direction is collinear with the force RC, and positive y direction is collinear but in opposite direction with force Q. So you have x and y, and we can write sigma fx is equal to 0 and sigma fy is equal to 0 here. And as it turns out, it will be convenient for us if we use sigma fy is equal to 0 first. This would imply, okay, we have 4 forces. Q is going down, so we will say minus Q because it is opposite to positive y direction. And then you have RA sine 60 degrees, that is the y component going in the positive direction, okay, minus F21 sine 30. These are the 3 forces, and the fourth force RC does not contribute any component in y direction because the angle between RC and y is 90 degrees. So from this equation you can find the unknown, that is RA sine 60 degrees, RA sine 60 degrees is equal to Q plus F21 sine 30. We know the value of Q, which is 445. We know the value of F21, that is 222.5 newtons and newtons here, from which you can compute the value of RA to be 642.3 newtons. Okay, this is the second part of the answer that we need. And from sigma fx is equal to 0, if you do sigma fx is equal to 0, that would mean you have RC, which is positive, okay, and then you have minus RA cos 60 degrees minus F21 cos 30 should be equal to 0, from which you can find RC is 513.82 newtons. Okay. In general, that is what we will do. We will choose an arbitrary x-axis and y-axis, and then write the equation sigma fx is equal to 0 and sigma fy is equal to 0.